Hey GED students, it's GED question of the day time, and it looks like an English question, but I promise you this is a math question. Let's take a look. It says, which of the following statements is true of parallel lines? Okay, so we've been talking about parallel lines, and we have said so far that parallel lines are equidistant from each other all through space. They remain at an equal distance because they're slanted the same way. Therefore, they never end up touching. Okay, so let's take a look at these four statements. I'm going to just kind of read through them first before I decide my problem-solving technique. So A, parallel lines have the same Y-intercept. Y-intercept. I start thinking of graphs when I hear Y-intercept. That's one of our graphing terms. Parallel lines have the same slope. Ooh, I'm getting more in mind of graphs here. Parallel lines have Y-intercepts that are opposite reciprocals, again with the Y-intercepts. And parallel lines have slopes that are opposite reciprocals. Okay, so you see I have a lot of graphing language here, so I'm clearly putting my parallel lines on a XY plane and considering them. So let us just plop two parallel lines down on a Cartesian coordinate plane. That's an XY plane where the horizontal movement is known as X movement, the vertical movement is Y movement. Okay, and let's kind of interpret these statements. So first one, parallel lines have the same Y-intercept. What do I mean by Y-intercept? I mean the same place they cross the Y-axis. But if you look at these two parallel lines, of course mine didn't cross at the same place. One was here and one was there. And I could have put parallel lines anywhere on this graph. So I could have put one here, that would be parallel with the other two, and it would have crossed there. Or I could have put a parallel one there, and it would have crossed there. Obviously, the Y-intercept has nothing to do with being parallel. I'm going to cross that guy off. Next thing, parallel lines have the same slope. Now remember what the word slope means. Slope means steepness. Take a look at these lines. If they're parallel, they are sloping. They are going down in this case at the same rate. If I had a line that was going down at a different rate, had a different slope, it would not end up being parallel. Let's get out a different color, like blue, and take a look here. Like if I started, but then I started going at a different rate, like I went down faster, sorry, clearly I would not end up being parallel. My lines would cross over and over again. And so parallel lines have the same slope. That's a pretty decent answer here. Let's interpret the others. Parallel lines have Y-intercepts that are opposite reciprocals. Now, I'm throwing language at you guys, but when I say opposite, I mean change the sign, so positive to negative. And when I say reciprocal, I mean flip a fraction on its head. A reciprocal is a fraction's multiplicative inverse. Now, it's the opposite when you multiply. That's what I'm saying there. But basically, you just flip the fraction on its head. Like, so for example, the reciprocal of 2/3 would be 3/2. Okay. So parallel lines have Y-intercepts that are opposite reciprocals. Again, we proved that there's no necessary relationship on parallel lines between the different Y-intercepts. We could have any Y-intercept really and still have the lines be parallel. Y-intercept has nothing to do with lines being parallel. I'm crossing that guy out. And then it says parallel lines have slopes that are opposite reciprocals. Well, we've already said if two lines have different slopes, they are eventually going to cross at some point. So it can't be this. They can't have slopes that are opposite reciprocals. So the only answer that makes sense here is B. And in fact, I wrote this question because I know that this is one of the statements you have to have memorized for the GED. You have to know that parallel lines have the same slope. This is part of the definition of parallel lines, and this is going to help you a lot when you go to do your graphing problems on the GED. All right, if you have questions about this or any other GED math concept, be sure to drop it in the comments, and I'll do my best to answer it.